Hello students, welcome to grade 10th Triangles part 2. Today we are going to discuss the basic proportionality theorem and its converse. This theorem states if a line is drawn parallel to one side of a triangle to intersect the other two sides at distinct points, then the other two sides are divided in the same ratio. That is, in the triangle, that means that in triangle ABC, if DE is parallel to BC, and then AD upon DB is equal to AE upon EC. Proof of the theorem. For this, we need to write given, to prove, construction, and also draw the figure. So what is given to us? It is given that there is a triangle ABC in which DE is parallel to BC. What we have to prove? We have to prove AD upon DB is equal to AE upon EC. For this, we will have to do some construction. That is, we will be making perpendiculars DG and EF on the sides AC and AB respectively. And also, we will join DC and BE. Now we compare the areas. Area of triangle ADE upon area of triangle DBE would be equal to half of AD into EF. Notice here, triangle ADE and triangle DBE. Area of ADE is half AD into EF, and area of BDE is half BD into EF, because EF is altitude for triangle DBE also. So these things they cancel and we have AD upon DB. Similarly, area of triangle ADE upon area of triangle DEC would be equal to half of AE into DG, and for this half of EC into DG. DG and DG cancel, half and half cancel, and you are left with AE upon EC. Now, we notice that these two triangles DBE and DEC, they are on the same base and between the same parallels. Therefore, their areas will be equal. We can take their reciprocal. That means 1 upon area DBE would be equal to 1 upon area DEC. Multiply both the sides by area ADE. Then we get area ADE upon area DBE is equal to area ADE upon area DEC, which implies that AD upon DB is equal to AE upon EC, because here we had taken this ratio is equal to AD upon DB and this ratio is equal to AE upon EC. If both of them are equal, so they will also be equal. Hence, proved. Now let us see the converse of basic proportionality theorem. The converse of basic proportionality theorem states that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. That means I need to prove that if DE is dividing these two sides in the ratio AD upon DB is equal to AE upon EC, then DE should be parallel to BC. Right? For again, this is a theorem, so we are going to write all the steps carefully. What is given? Triangle ABC. DE cuts the lines AB and AC such that AD upon DB is equal to AE upon EC. To prove that DE is parallel to BC. Construction, we draw a line L. Now, suppose DE is not parallel to BC, then there should be another line L which should be parallel to BC. Now, if L is parallel to BC, then by basic proportionality theorem, we should have AD upon DB is equal to AF upon FC. But it is given that AD upon DB is equal to AE upon AC. So now, these two things they are going to give me that AE upon EC must be equal to AF upon FC, which is possible if and only if F and E coincide. That means, or we can say, which is possible only if E and F